All right, so we're going to continue to look at 1.7 functions. So we're building on this. Before we learn basically solving function notation and how, basically again, functions are when, every input has exactly one output. We talked a little bit about the vertical line test, where if we have a graph, we can take a vertical line through the graph, and if that vertical line touches the graph exactly one time, it is a function. And then we explored how we can use function notation to determine the output for every input. So again, 1.7 functions, we're going to continue to this, and we're going to continue looking at function notation. So the first one we're going to look at is, okay, so we're going to continue to build on this. So we have g of x equals 3x minus 11. All right, so if we remember here, g of x is just a function, and the function is 3x minus 11. We're going to learn eventually that that's going to create a graph. But right now we're looking at trying to solve and figure out what exactly that output is for the input. So the first example we're going to look at is g of m. And now you may be sitting there going, thinking like, Mr. Harris, there's like g of x, that's a variable. Now you just gave me another variable. Like what? This is still, we can input m, where we're showing we can input anything into there, but we're only going to get one output. So g of m is basically what it's saying is, g of x is 3x minus 11. G of m, we're going to substitute m anywhere there is an x. So there's going to be a 3. And then in place of x, we're going to put m, and then minus 11. So g of m is just 3m minus 11. It is that simple. All we're doing is we're substituting m in for x. These are not like terms, so we cannot combine them. All right, so g of m is just 3m minus 11. But now what if we have g of m plus 6? Like, oh my goodness, we were dealing with just numbers, and now we got a variable, and now we got a variable and a number? All we're going to do is we're going to take this m plus 6, and we're going to substitute it in for the x variable. So we're going to have 3 times, so in place of x, we're going to put m plus 6, and then minus 11. If we look here, we have distributive property. We've learned distributive property, so we're going to use our rainbows. 3 times m is 3m. 3 times 6 is 18. Hey, look, we have like terms we need to combine. So 3m plus 16 minus 11. We can combine 16 and 11, and we get 3m plus 5. Okay. So g of m plus 6, we plug in all of m plus 6 into the variable x. We solve, and in the end, we always look to see if things are in simplest form, meaning there are no like terms and there are no more parentheses. All right, so what I want you to do, I gave you an f of x. I want you to try this one on your own. So what I would like you to do is I would like you to pause this. It's kind of tricky. It's got 2a, but I think you got this. I want you to pause this. And then I want you to try this on your own. So we're going to pause this. Pause now. All right, so now if we plugged in f of 2a, we should have gotten negative 8a plus 7. If we plugged in that 2a, we still have to take the negative 4 times that 2a. That's what gives us that negative 8a. If we did f of b minus 3, we plug in b minus 3 in place of x. We distribute the negative 4. The trick here is negative 4 and negative 3 gives us that positive 12. And then we combine like terms. All right? All right. So remember, if you're still stuck on some of these, when we stop after this and we say, are there any questions? Feel free to make sure you ask those questions. So maybe put a little note down like, hey, I don't quite get with this variable, or what's going on with the distributive property. Put that down so that you have questions when I ask if there's questions. All right, the next one. F of x equals x squared plus 3x. Whoa, we've got 2 variables in here. Well, they're kind of the same variable. They're all x. But one of them squared. So we cannot combine those because they're not like terms. But we're still going to follow the same rules. So we want to know f of 4. So f of 4, we're going to plug 4 in place of any x. So we're going to have 4 squared plus 3 times 4. Because remember, we're inputting that 4 into anywhere we see an x. And now we just solve. 4 squared is 16. 3 times 4 is 12. So f of 4 is going to give us 28. And then we're going to plug in f of 2m. So f of 2m is going to be 2m in parentheses squared plus 3 times 2m. Okay. Well, 2m squared, we take 2 squared. 2 squared is 4. And then we do m squared. Well, m squared is just m squared. And then we do plus 3 times 2 is 6 and m. These are not like terms, so we cannot combine them. So f of 2m is 4m squared plus 6m. All right, so hopefully you got that. If you didn't, you put a little star by this one. All we're doing, remember, anytime we see this function notation, all we're doing is we're substituting. We're taking whatever it tells us to input and placing it in for the variable. All right, so let's try this one on your own. So I'd like you to take the time, even though it's x cubed, you can do cubes. Even though there's an x cubed, I want you to try this on your own. So if you could, please pause the recording now. So when we inputted these, so we did h of 5, we plugged in 5 for every x. We have 5 cubed minus 4 times 5. 5 cubed is 125. 4 times 5 is 20. So we got 125 minus 20 is 105. And this one, when we inputted 3p, we have 3p cubed. Well, 3p cubed. 3 cubed is 27. P cubed is just p cubed. Minus 4 times 3p is 12p. These are not like terms, so we cannot combine them. So this is dealing with function notation. You have various types of avenues, various types of questions. If any of this is still confusing, you're like, hey, I want to see another example of the ones with the exponents. Put that down so that when we pause afterwards and we're like, is anybody confused about anything? You can be like, hey, can we do another example of this one? All right, hopefully you enjoyed the video.